Hello, everyone. We're ready to get started with the CDRE, the Center for Disaster Research and Education virtual seminar series for the fall 2011. Today, I'm very pleased to introduce Dr. Jay Parrish, who's a professor of practice for geospatial intelligence in Penn State's Dutton E-Education Institute. His primary areas of expertise include image processing, remote sensing, and geobotany. Dr. Parrish has worked in state and local government, initiating the creation of geospatial data and applications. He has also served on geospatial academic advisory boards and organized numerous remote sensing workshops. He teaches remote sensing in Penn State's Master of GIS program, has served on the National Geospatial Advisory Committee, as well as president of the PAMAGIC, which is the State Geospatial Organizing Committee, and also as acting GIO of the Commonwealth. He also conceived and oversaw the creation of the Pennsylvania map, a component of the national map, which includes statewide LIDAR programs. He also worked with Pennsylvania State University to create Penn Pilot, which is a data repository of scanned historic aerial photography. Before joining Penn State, Dr. Parrish worked as a geophysicist for Mobil Oil, Dallas, a remote sensing specialist at Geospectra Corporation, Ann Arbor, and a research assistant in radar geobotany with Ball Aerospace at Caltech's Jet Propulsion Laboratory. I am very pleased to introduce Dr. Jay Parrish, who today will be talking to us about the Marcellus Shale in Pennsylvania. Go ahead. Thank you so much for joining us.
Okay, thank you. Thank you very much. So you should be seeing the first slide, which shows you the actual Marcellus. The Marcellus is a pretty, what's the right word? Nondescript rock. It's a basic black shale, which for many years did not get people too excited. And so we'll come back to that. But go ahead to the next slide. And a little bit about me, you already heard that I'm a professor of practice at the Dutton Institute at Penn State, and I was a former state geologist. As my son would say, who really cares? Because, you know, king of the rocks and who cares? I mean, it's a very small world that cares about the geologic resources of our state, and yet today it's become very important. I do have a doctorate in geophysics and I'm a professional geologist, and a PG is required for all geologic work in the state except for oil and gas exploration. So everything that we're talking about today, there's no requirement for any certification. Next slide, take you to the Drake well. It's over 150 years ago. We had the first well in Pennsylvania, and if you go up to the Titusville area, you'll find that there are just hundreds and hundreds of uncapped wells everywhere. The early days of oil and gas exploration in the state, there being no regulation whatsoever. We've pretty much punctured the entire western part of the state with holes, and you have a lot of problems with contamination as a result of that. We've learned from that, and nowadays there's a lot of regulation about what happens with an oil or gas well and how it interacts with the near surface. Go on to the next one. You should see the map of Pennsylvania with all the documented oil and gas wells. The word documented is very important because for the first 50 years or so, there really were no records. We have no way of knowing where all those wells are. So these are just the ones that have been around since about 1900. And all the ones prior to that are just sort of no regions where they drilled. Many of these wells are also not capped. But you can see that the predominance of them are in the western part of the state, and were drilled in a couple big bunches time-wise. So if we go on to the next slide, there's a picture of when they were drilled, and you'll see that in the 1950s there was a lot of deep drilling down to the Oriskany, and then you come up into the 80s, and there's a lot of shallow drilling when the price of energy became higher, and people started re-drilling shallow plays. And then you get into the late 2000s, and there's a sudden spike, and that's the Marcellus impact. Go on to the next one. I'm going to thank John Harper at this point, who is the primary oil and gas geologist for the Pennsylvania Geological Survey in an office in Pittsburgh. And he has done an excellent job putting together a lot of slides. And so I'm going to be using some of his slides. And I thought I'd take a second just to say that if you really want to know anything, you ought to talk to John. Survey for 25 plus years and knows the subsurface of western Pennsylvania like the back of its hand. Go on to the next one. One of the reasons that I keep bringing up to the survey is that they're the stewards of all the well data. They take the data that comes from DEP or anything that is delivered to the state, and they put it into a database. One database takes care of where the wells are and what you know about them. The other has all the images of the well logs that are available. And those two databases are essentially all that we know about the subsurface in Pennsylvania. And they'll come back to that, but the vast majority of information comes from those two. There's also a geochemical database, and anytime new information comes in about thermal maturity or anything like that, it all gets entered into that. You can go to their website, which is listed there, and find out more about what data is available. So many of the things that I'll be talking about today are all based upon these databases. You will rarely hear them mentioned. They're WIS and TA-IRIS, but they are really the foundation of everything that we know about the Marcellus. Next one, please. So you've heard about incredible production rates and an average initial flow of, I am clicking this, and you are not necessarily seeing it the same order I am. So I apologize for that. Go ahead and just display everything on this slide. But the average initial rate can be up to 1 million cubic feet of gas per day, with the rates averaging 4 to 5 from vertical wells. And you can have initial flow rates that are extremely high. I'll just leave it at that. And we'll go on to the next one then. And what we'll see here is that what they all have in common is an average initial 24-hour well, let me just stop and say, look at the red parts. The red parts all say initial 24-hour, average initial potential. They're all basically saying the same thing, which is as soon as you open up a Marcellus well, you get a lot of gas coming very quickly. Very quickly. It's a lot of it. And the other half of that story is it also drops off very, very rapidly. So when you hear about a new well coming in and it has tremendous flow rates initially, that will drop off extremely rapidly. And that initial rate will not persevere for very long. So we get all excited when we see the initial rate because we're used to wells that produce a little bit more steadily. And you figure, well, if it started at this, it'll only go down a little bit. And so this will be a tremendous well. These initial rates are absolutely phenomenal. They're huge, but they also go down rapidly. So let's move on to the next one, which is a geologic map of Pennsylvania. And the blue is essentially Pennsylvanian and Permian, some Devonian and Silurian rocks outcropping down in the Ridge Valley. But most of it is the area where the Marcellus is in the light blue and the northern tier of the state. You can see just looking at that the geology there is much less complicated than it is in the center and down to the south. And so we have fewer faults to be concerned about, fewer folds, a little bit easier to figure out the geology there. But we also have poor outcrops, and the only information we really have about things is from those wells that have been drilled previously. And the next slide shows where those wells have been. If you look at all the oil and gas fields in Pennsylvania, it correlates pretty well with where all the wells were drilled, not surprisingly. And this is prior to the Marcellus. And as you'll see later, the Marcellus fills in the north central part of the state. We we know something about the structure out there from the wells, and then from gravity, magnetics, landsat imagery, and things like that, we can infer other things about the basin. So the next slide shows you a basement map of the state. It's a little bit difficult to see, but you'll notice that there's a lot of dotted lines, which means we don't really know where things are, and there's some straight solid lines, which are hypothesized zones of fracture, not necessarily faults. But we still don't have really good evidence for a lot of those things. And so a lot of the information that we're talking about is all inferred from seismic line, well, from the well data, seismic lines, gravity, magnetics. We just did in 2009, they did a seismic line going from Lebanon down through Lancaster County, which tells us something more about that region and kind of ties together. What you see is on that map is that you have a lot of information in the southeast, and then there's sort of a white area that goes up from there, and we don't really have a good idea how those two fit together, and this helps with that. Essentially, what we're looking at is that there's a basin which is very shallowing off to the northwest, and so the Marcellus is going to be relatively shallow as you go up towards Lake Erie and very deep as you come to the center part of the state. And it's folded and faulted and messed up as it gets closer and closer to the colored part of that map. And so that part has been heated, and so we suspect that there's no potential for hydrocarbons there. So let's take a look at black shales here. Next slide. We're talking about Devonian black shales here, and they tend to be relatively thinly bedded, rich in carbon, sulfide, and organic matter, which means that they were anoxic, low oxygen conditions. It's like a mucky, nasty swamp that has a lot of hydrogen sulfide. It's high in sulfur, and you usually tend to avoid things like that because sulfur is a sure tip-off that you're going to have troubles with anything you burn because you want to get rid of the sulfur before you burn it. So for many years, we knew that there was a lot of gas in the black shales, but again, as you drilled them, you produced gas for a little bit, and then they would go down to nothing, so it wasn't worth producing. And then there were the problems of the sulfur and the radioactive materials and things like that. But what changed all that, as we go to the next slide, is that Terry Engelder used this slide, and I borrowed from him, that Hubbard, the famous petroleum geologist who worked for an oil company and discovered that there's a kind of a lag time between the discovery wells, when you get a lot of wells drilled, and then the production, and then it dies off. And the time between the maximum discovery and the maximum production is about 27 years. So if you discover a whole bunch of gas today, usually there's a 27-year lag before that translates into a big bump in the market later. If we go on to the next one, in our case in America, we were heading towards the end of our initial big bump of discovery, and it was going down. As you can see, the blue line is going down. And what has happened instead is that the green, the unconventional product, which means the black shales, has gone up. And instead of that being a nice normal Gaussian Hubbard curve, it's now going up again. So we kind of have this big bump. And essentially we're getting about a 20-year reprieve in the decline of oil and gas in the country as a result of that. So we'll go on to the next one. And the reason it's called unconventional is that a conventional well would just go straight down into a sandstone formation where there's lots of porosity. The gas would filter into it and you'd pump it out. And the Marcellus formation, being a nice tight clay, would act as a seal and keep the gas from moving upward. And so you would be drilling below it and getting the gas that's trapped by it. Instead, what we're doing is going to the trap which is contrary to most people's opinion. The models for how you look for oil and gas, going to the trap and fracturing the track and getting gas out of that, which is unconventional to say the least. So if you go on to the next one, if you just drill a simple vertical well, you only get a little bit of that area fractured. You're not going to get as much gas coming from it. But if you go horizontally through it and fracture it, you're going to get a lot of gas, a lot more surface area, and a lot more gas over a longer period. So naturally, it makes a lot of sense to do that. You go to the next one, it increases the amount of area that you're drawing from, and then in this curve, it shows that also got a much longer production, bigger. You can also see on this curve on the left, you can see how rapidly it drops down. We're going to see that that's even more accentuated than that later. Move on to the next one. So you say, well, what's changed in the mind of people between a conventional approach and an unconventional? And the difference is that you have that model change, which is hard for people to do, from viewing shales as a seal to viewing it as a source rock. You have a technology change in that the drilling can actually be controlled enough to do the horizontal drilling. You have the ability to use massive amounts of water. Many times when we're looking for oil and gas in other areas, there wasn't a lot of water around anyway, and so that would kind of preclude doing that. Now they're drilling in areas where there is water, and it's easier to do. You have higher energy prices. There's a lot of demand for gas, but the prices have not actually gone up lately. They were high and they've gone down, and so right now they're not as high as they should be for most people's estimates of what would make it economic to do this kind of exploration. And that brings up another issue which we can talk about later. But at a time like that where the price is not very high, it makes you wonder why the state would then lease their land because the price isn't as high as it ultimately would be, perhaps. And then you get into the Wall Street's acceptance of unconventional plays, such as the coal bed methane and tight gas sands and oil shales and shale gas. So people are more willing to invest in that. So to review again, we go on to the next one. You normally have a seal, number 5, the shale that holds things in, and the gas is below that. And what you're looking at in the next one is the source being in a sandstone, which is usually a resistant rock in Pennsylvania, which are pretty open and have a lot of pore space. If we go on to the next one, there's a thin section which shows you the pore space, and the sand grain is white and the pore space in between is blue, and so that's where the gas is migrating through. But if you look at a shale, which is the next one, you can see that the shales are much tighter. There's no porosity that you can see with the eye. I mean, with the eye, you don't see anything, obviously, but you can see that it's pretty solid. It's just clay. And if you go on to the next one, it shows you a thin section of the clay. You can see that there's no pore space at all. It's solid clay. That means in order to get the gas out of there, you have to fracture it in some way. And one way that we look at it, as we go on to the next slide, is that there's joints. There's actual natural joining in the rocks that allow gas to migrate along those. And so you can drill preferentially to try to hit those joints. In the Marcellus, they actually are pretty beautiful. There's up in New York, there's some outcrops that show just how beautiful the joining is. I mean, it's a very nice place to go. That provides one way of having the gas migrate. The other is to then break that up some more. If you go on to the next slide, it shows you where the shale gas production was up till the unconventional approaches. And for almost 100 years or more, along Lake Erie, they used to drill very shallow wells that had very, very small flows, very little pressure. and they would last for decades, but they wouldn't produce very much. So it's the kind of thing that you didn't invest much. You had a well that lasted forever, but you got a monthly check for $1.95. It's a very low amount of money, but it was very consistent, and that's kind of where people thought of the Marcellus until before the fracking. So if we go on to the next slide, there's if you look at the major shale plays in the United States today, you start seeing the production rates. And now you can see what I'm talking about with the drop-offs. If you look at the first year, you drop off very rapidly down to less than a fourth or so, or about half for most of the others. And then it's relatively consistent for a long period of time, but it goes out for many, many years at a very low rate. So when it came time to talk about a tax or a fee on this last year, under the Mandela administration, they considered a tax that would exempt the first year's production, which, looking at this slide, you can see the vast majority of not the vast majority, but a large chunk of the gas produced is produced in the first year. And they also defined it as a Marcellus tax, never mentioned the other horizons. So you can see that if you passed our Marcellus tax or Marcellus fee, all the other black shale horizons would also be open to not being taxed. And so you'd actually have to go back and pass another tax for each one of those horizons, unless you change the language to say from any unconventional gas production or something like that. But without looking at that production curve, you wouldn't necessarily have thought that was a bad idea to say, well, let's just have the first year be exempt. Going on to the next slide, you have the cumulative cumulative production, and then the daily decline, and you see that they cross over there. And so that after the first or second year, you have the majority of the gas out, and then from there on out, it's a very little bit of amount. So that after a while, after 2 or 3 years, it becomes cost effective again to go in and refrac and boost that production again. So instead of being a deal where you drill once, frac, and then go away and let it produce for decades, it's more likely to be a case where you frac, let it go a few years, and then come back and do it again. Going to the next slide, what happens after the Marcellus declined, you probably are going to re-drill and refrac. This could go on for years, and you could go for other layers. Maybe only after Marcellus, you could go after the Utica and others like that. The other gases in the other layers tend to be a little wetter, which heavier hydrocarbons, and present other problems. So let's move on to the next slide. At $4.50, depending upon the price of gas, it's kind of a low price for natural gas historically. And so then you wonder, well, why would the state sell leases on state land at the bottom of the market? Why not hold on? That being one of the arguments used to say why we shouldn't be drilling on state land at this point. Go on to the next slide. So what about production? We have very little information about production because we don't have very many wells that have been producing, mainly since 2005. And we have to keep all well data confidential for 5 years. So we can only aggregate things for statistical analysis, so we don't give away too much information. So we don't have a lot of detailed information about production in the Marcellus and Pennsylvania. And that is, again, a legislative issue. But if you look at the average of all Marcellus wells, you can see the production falls off dramatically after the first year, and in outgoing years, it's relatively low compared to the first. And if you look at the vertical wells, next slide, which has the blue bars, you can see that it has relative, the production, you can see there on the left, the units go from 100 to 500. If you go on to the next slide, if you look at the horizontal wells, you can see that the production is much, much higher, going from 0 to 1,400. So you can see why people want to do the horizontal drilling. You get much higher production. You still get the fall off, but you're falling off from a much higher point. If you go on to the next slide, there's a comparison between the vertical and horizontal wells, and you can see that the first year is the big important year in terms of production. That's where all the money is being made, because you're getting a tremendous amount of gas coming in, and after that it dies off very rapidly. On to the next one. And you can see here, if you look at average daily production rates for wells of other horizons we look at in Pennsylvania, Risky being one of our biggies, the Medina, and things like that, they produce much less than you get from Marcellus well. So going on to the next slide, there's the risks and challenges of Marcellus producers in Pennsylvania. One of them is that we actually have topography, which is a good thing in most cases. It makes it difficult to drill wells if you have to clear a 5-acre spot and you want it to be level. We also have a pretty well-distributed population that means that we have population centers all over the state. We have a pretty old pipeline system, which is being rapidly upgraded, and it is brings with it a whole set of other problems. But what you'll find is that most of the wells that are drilled are being drilled along where pipelines are being put in. And then, of course, there's the water use and disposal issues, which everybody knows about. There's also the problem that we have fragmented mineral rights ownership, so that you might have land that has been split up over time in inheritance, so that the surface owner might not own the mineral rights, and the mineral rights might be owned by 200 people because it's been split up and divided over so many years. Then we come to the last one here, which is gas leakage, groundwater contamination, geohazards. This is something that's real, that requires study and has been largely ignored. So we'll go on to the next slide. You're familiar with with the amount of water that's needed. So you need millions of gallons of water per well. Now, it's often said that water is reused, and so that is true, so that you don't lose all that water on the first with each well, but it is ultimately put underground in some way, and some of it doesn't come back up. So we'll move on to the next one. The water resource concerns is that you have to have enough water available, and the Susquehanna River Basin Commission and Delaware River Basin Commission have taken two different approaches to that. But there's things in place that say that if the Susquehanna River Basin doesn't have enough water, they'll stop providing it for drilling. And there's concern that once the water has been used, it won't be disposed of properly. And of course, there's many anecdotal evidence of people seeing trucks dumping things and things like that. So there's always that problem, and it becomes a matter of cost. If we don't have enough of a penalty for pollution, it becomes cheaper to pollute than not to. So we'll move on to the next one, which shows some of the problems with the water use and disposal issues. So you get a lot of flowback. Flowback is water that you put down in and it mixes around down there and comes back up. And the problem with that is that it comes back up, you put it in as fresh water, it comes back up containing ancient seawater salts. So they're concentrated brines, which come back up to the surface. The black shales do a good job of concentrating metals. You have some metals in there, and you have the hydrocarbons coming up, which is to be expected. And then the black shale does a great job of concentrating radioactive material. So it actually comes back up as a little higher content in radioactive material, which our water systems are not usually set up for removal. So that's one of the concerns with the flowback fluids being re-entered into the environment. We'll move on to the next one. So the exact list is one of those issues that people have debated, and that there's been legislation about that they're supposed to release exactly what chemicals are used, and then companies say some of them are trade secrets and percentages are trade secrets, but everyone agrees upon the general trend of what kind of things are in there. Water and sand are the two biggies. You put in hydrochloric acid to dissolve out the calcium carbonate, and then you throw in a whole bunch of these other things, which are in relatively small concentrations, but remember you have huge volumes, so the actual amount going in is still pretty large. Interestingly enough, the quartz sand that goes in has to be the right size to hold open the fractures, and so there's a pretty high demand for certain sands that are just exactly the right size for that, and develops a whole new industry because of that. So move on to the next one. You can see what a typical drill pad looks like. The law says that if you keep it under 5 acres, it's a lot easier regulatory-wise, and so they're keeping it under 5 acres. And you can see here that they have some pits where the drilling materials are drained to. And when they're done, that'll all be covered over and planted back with grass. But you can see that they've changed topography. They've built a flat pad. It's never going to be the same as the farmland that was behind it again. It's going to take many, many years to recover from that. But most of the land could be reclaimed except for the center where the drill is. So you go on to the next one. During the actual fracking process, there's so much water and chemicals that have to be used that it's hard to fit all of the trucks on the site with all the materials. And so it becomes pretty cramped. But during the frac, there's a real crunch for space to do this. We'll move on next. You've all seen this. It's just illustrating that you're breaking open the fractures and then you throw the sand in to try to keep it propped open and allow the gas to come out. Next one shows DEP's map of active oil and gas wells, and the red show the Marcellus wells. This is 2 years old now. But you can see that the development is in the north central part of the state and then down in Washington and Greene counties, southwest corner of the state by the two big areas. And the next slide shows what this had in its database for all the Marcellus wells. So what does that tell you? Well, it tells you that WIS has a whopping 300 wells that they say that they have. The DEP says that they've issued thousands of permits. And so there's a big lag between how much data gets into the database and how many permits are allowed and how many wells are actually drilled. And there's not much of a penalty for a company that's late in delivering data. And so many times you'll find that the information just doesn't make it into the state database in a very rapid fashion. And they can hold on to it for a year or two on the pretext that it's still an active well. They haven't completed it, so they don't have to turn in the information. And so they can drill the well, do everything they want to with it, and until they actually say, well, now it's complete, they don't have to turn any information in. If it's a particularly good well, it's their advantage not to tell anybody else. And so data on those wells just never makes it into the database. Going on to the next one, you can see where the state land is and where the Marcellus is, the Marcellus being the hatchered part, and the rest of the colored areas are state-owned land. And there's a pretty high correspondence between where the Marcellus play is, where the interested area is, and where the state land is. And that's why it's become such an issue. It's very big target for the companies to hit in terms of dealing with just one landowner instead of having to deal with the thousands that they usually do. We'll move on to the next one. And here comes the shocking part. In terms of actual samples of the Marcellus that we have from drill holes, this is all there is. It's a very nice, even disbursement of samples, but that's not much information. consider the thousands of wells that are being drilled, we don't get that information at the state. As the citizens of Pennsylvania, we don't get that information necessarily. If it's on state land, we might get that information if we ask for it. It all depends on the state agency and whether they ask for it or not. And we don't have a place to store all this. There's currently a storage at the State Geological Survey that's rapidly going to run out of room, and it's very difficult to find space to store rocks because when people look at budgets, the first thing they say is, well, why should we pay to store rocks? But as you look at this, you can see that all the discussion that we have about the Marcellus and the impact, economic impact and environmental impact, we're dealing with very, very few data points to make all of that scientific discussion. Go to the next page. There's no real systematic effort to collect data from the energy companies for all the wells they're drilling. And there being very limited core storage space, and there's few offers from the companies themselves to share the core. So there's just not much information being collected. When you consider the millions and millions of dollars being spent on collecting the core data, it's a minor expense to store it, because to go back and recollect that data would cost you, hundreds of millions of dollars. So to get it for free from a company that drilled it would be a real bargain. So that's one of the great problems with the whole Marcellus push going on right now, is that the emphasis is upon local government getting money for roads and taking care of immediate problems, but there isn't really an advocate for collecting the basic data that will help us understand what's really going on with the Marcellus. And this is a real key problem. We go on to the next page. The state actually had a hand in this. When I was with the state, we spent $24 million on imagery and LIDAR for the benefit of county governments. The data was put on POSDA for download for free, and what we found is that 90% of the downloads came from energy companies. So in effect, we made it possible to collect this data. We collected all this image and LIDAR data, and made it possible for people to explore at a lower cost, and they didn't have to pay anything for it, and they didn't contribute towards collecting the data. And you say, well, why would we have done that? Well, the idea originally was to benefit county governments. And if we go on to the next one, the reason that we would want to continue to do it is that it's the only way to capture this portion of our history. If you want to go back in time and see what was happening where or when, you can't rely upon individual photos on the ground of what's happening everywhere. You need to have an air photo which shows you, covers every inch, so that you capture everything that happened, where every pipeline went, where somebody may have dumped something, so that 50, 100 years from now, somebody can go back and say, aha, this is what happened to this area. If you're in environmental geology, this happens all the time with real estate. You do an environmental site assessment. You go back in time. You look at everything that happened as far back as they have air photos to see if anybody was dumping chemicals on the property or if it was really cared for before somebody buys the property. But in effect, it's priceless data. Many times in it's like a property transfer, you would have millions of dollars involved in a property transfer, and one photograph could tell you whether it was money that was going to cost you more millions or whether it was a good transfer. So it's really priceless data. If you go to the next slide, it shows you what I'm talking about. This is PA map data from 2004. You can see the deciduous trees have the leaves off, and then the conifers are the green ones. You can see a pipeline going across the middle of the image, and there's two green dots. Those are where we're going to see wells drilled in the ensuing years. So if we go to the next slide, 2008, we got imagery again. You can see that on the top one, there's a little bit of activity going back to that well, and so they're just beginning it. But for 2004, 2008, we saw that not much was happening in that part of the world. If we now go to 2010, you can see what happened. You have 2 wells that have been drilled. Actually, down to the right, I think, is a borrow pit for construction that was probably instigated by having all the development in the area. So you have 3 big chunks and some roads built through the woods that weren't there before. To quantify the effect of the drilling, you've captured it now, and it becomes possible to go back and say, okay, here's when those trees were cut, and here's why we have a fragmented forest here or whatever. You wouldn't have any way of knowing what was done to the land otherwise, because no one else is recording that. What you'll notice is that this is MAPE data from 2010. MAPE data is acquired during the summer when the leaves are on, and so you usually see less. And the reason that it's there is that PA map data didn't get acquired. So we'll go on to the next slide, and we'll take another look at 2004 PA map data. You can see each individual tree because there's 1 foot spatial resolution on these. And if we go to the next one, you can see that in 2008, they were beginning to do some bulldozing and getting the site ready. And in 2010, there's the site and there's the well, the well out there. So you can see that this would be a very useful tool for anyone who wanted to look at environmental damage or environmental change as a result of drilling. It's extremely useful, and you can also probably not be surprised to know that then the PMAP program was defunded. So there's no money in there for getting data anymore. So we've got data for a couple of years before a lot of the drilling occurred, and now there isn't any. So most people then say, well, that's not a problem because, going to the next one, doesn't Google already provide air photos? So here's Millersville's campus, and you can see that there's air photos on Google. And if you look down at the very bottom of that, there's a little bit of a white fuzzy line. And we'll take a look at the next slide. And what that little fuzzy line says is PA Department of Conservation and Natural Resources, PA map, USGS, that the data on Google Earth actually came from PA map. So, yeah, it's true. You can get that data on Google, but it came from PA map in the first place. Without it being collected, Google will go ahead and get data, and I'm sure they'll keep making it current, but it won't be systematic in terms of collecting it leaf off so that you can see what's happening under the canopy of the trees. And there aren't the same specs that you had for cloud-free data and accuracy. So moving on to the next one. We're essentially blind when it comes to high-resolution data. It only took about $2 million a year, or $2 million, to get imagery of the entire state. Since there's no plans to utilize fees to continue doing that, any scientific data that we collect from this point on will be based on a map that's at least 3 or 4 years old, if not more. So the base map that we use is always going to be out of date. And if you want to look at environmental changes, it's going to be very critical that you have an up-to-date base map. Going on to the next issue, stray gas. We have natural gas leaks in the rock. They're very common. Duke did a paper recently that showed a correlation of stray gas and drilling. Not that it was caused by drilling, but correlated, which is not surprising. If you're drilling for gas, you probably are in an area where gas is leaking to the surface anyway. But there was never the ability to do a baseline study of our whole state to know what was there before we started drilling. So we'll never actually know the effect of the drilling. Without the baseline study, all you have is after the fact. And frankly, most people didn't think of lighting their spigots until people started suggesting it lately. So you don't really know how many of those spigots would have lit on their own before you did that. You only know what happened after the fact. And so that lack of the ability to having a baseline study done is really a huge gap in the ability to monitor what's happening with the Marcellus. It's really a matter of great importance that they do a study even at this late date to at least get the areas that haven't been drilled yet to get some kind of baseline information. The next slide is about water wells, and Pennsylvania has absolutely no regulations on water well construction, and we're one of 2 states that don't. Everyone else does. So you can drill a well, and you can actually be a water well driller if you have $60, I think. So anybody can get a license to drill and leave and do whatever they want to with a water well. There's no way to enforce anything about water wells. So although we're very concerned about oil and gas drilling and are interested in its contamination of water supplies, a far greater problem at this point is actually water supply wells that are not done with any proper construction. So it just brings up another problem that we need to address before you can even look at the problem of the interaction of well drilling and gas drilling. But even so, to use a slide going to the next one of my friend Volkachanov, it makes an explosive combination to have gas drilling in an area where you have poor water well construction, and you're bound to have some kind of surface contamination from any activity. And so you end up with people justifiably upset because their water wells contaminated. You don't really know the source in all cases, and it would be good to, again, get that baseline study done before things come to that point. Moving on to the next slide. Another issue is induced seismicity. If you inject fluids, people know that you create earthquakes. We have a seismic network in the state. It has about a dozen seismometers potentially funded, but it's been a very low amount, about $50,000 over 3 years. Not nearly enough to monitor everything, so we won't have the ability to really respond to induced seismicity reports, nor to monitor it. So we're partway on the way to getting it done, but we're not really quite there. Once again, if you don't have the seismic system in before the drilling starts, you can't tell what before looked like. You only can tell what happened afterwards, and it's very difficult to show that something was caused by something if you only started recording after the problem occurred. Next slide. One of the other big issues for us is that in over a decade, neither the governor nor the legislature ever asked the Geological Survey for information. So most of these laws that are being talked about and the fees and everything else are being made in the context without any geologic data being brought into it. I do want to point out that one legislator did ask for information after I asked him to ask me about it. But generally speaking, there's been no communication that way. It's something that really has to change because it's imperative that if you're going to have something as big as the Marcellus impact the economy of the state and the environment of the state, that you get good scientific information. So it seems like a thing I want to advocate for. Next slide. So what should we be doing? Well, we're doing something to the state, a large area of the state that can't be undone or cleaned up. It's whatever you do, you've done it. So by doing that, you remove other options in the future. We don't really know what those limitations may be because we really haven't studied it. We don't really have a good understanding if it has an effect, a bad effect or not, or what effect it might have. So it seems to me that some study would be a minimum that we should be doing that. New York sort of sat back and said, we'll see what happens in Pennsylvania, but now they're going to be going ahead. But they've done a little better job of trying to get some preliminary data acquired. So the next slide says that some of the studies that really should be done before anything else goes on is a stray gas background study and induced seismicity network set up and collect current aerial imagery and a recollection of LiDAR so you get topographic change so that you can see change of land use and topography, and then apply all that to an intensive study of a pilot area where you really do a great job of looking at the subsurface with seismics and geologic mapping and everything else. I wouldn't be honest if I didn't say that this doesn't open up a new world for geologic mapping, which is the next slide. You have the opportunity to do a lot of good science if we make use of the data that's rapidly being lost from all the drilling going That brings me to the point of questions. My next slide is just how to contact me. But I'd be delighted to talk to you about anything that you may have thought of while I rambled on here.
Thank you so much, Dr. Parrish, for a very informative talk. I did neglect to mention that you did serve as the Pennsylvania State Geologist and also taught some wonderful courses for us at Millersville. So thank you again for joining us and for providing this talk for our students, and some of the faculty have also joined us for this seminar. I would like to open it up for questions, if that's okay with you.
Sure.
Questions? Well, I'll start with one. I was wondering if you're aware of any major studies that deal with the effects of drilling on air quality. So there's a lot of water quality studies, but I was just wondering if you knew of any in Pennsylvania.
Well, I know it's something that they've talked about. I'm not aware of any completed studies. I know they've done some small studies, I think, within DCNR and DEP, but I'm not aware of anything that was very comprehensive, and that's just might not be, there might be something, I just don't know. But it's certainly something that would be worth looking at. I've been looking at using satellite imagery for that, but of course, the resolution's too coarse, I think.
Right. Yeah, I came across a report that was initiated, as you said, by DEP, and they had some, mobile sensors that they did some air quality samples or air samples for only short periods of time. And the results showed, some spikes, but the duration was too short, and so it would be interesting maybe to look at something that's over a longer duration and monitoring various, particulates.
Yeah, and there's, I was recently in Switzerland, and there's a company there, actually a Finnish company, that on a regular basis flies areas like this looking for hydrocarbon leakage. And they just fly it with a small aircraft on a regular basis. And it seems like that's something that we should be able to afford to do.
Right. Yeah. Do you happen to know the name of that company, or?
Second?
Or I should be able to find it on the web?
Yeah, SPECIM is the Finnish company. And the Swiss company was Medio something. Doesn't help you much. I'll have to look up my notes.
Okay, great. Thank you. Are there any questions for Dr. Parrish?
Hi, Dr. Parrish. This is Paul Sharp. I'm one of the emergency management faculty. You mentioned there was no requirement for Pennsylvania to drill water supply wells. That's for, I would guess, both public and private systems?
There's no requirement. No, I'm not really sure about public, but for private, I know there's not any requirements.
So I guess that means that the shale drillers could sink a well literally adjacent to someone's water supply system, and that would really contaminate their well, I would guess.
Well, if they did it correctly, it wouldn't. If the water well were constructed properly and were cased, and they drilled a gas well next to it and cased it well, there shouldn't be any problem. The problem arises in that we have no regulation about the water well, so the water well could easily be wide open, and therefore anything that's spilled near them, if anybody knocks over a gas can, is going to go right into their water supply. And that's the failing on Pennsylvania's part.
Any other questions?
I have another question, Steffi. With regards to the fracking fluids, are you aware of any studies that show the solubility of some of the shale components, whether it's a synergistic or additive effect due to the fracking chemicals?
I know some oil companies have done those studies. I'm not aware of publicly available ones.
All right. So a lot of this information, then I guess the companies can claim this is proprietary information, and they don't necessarily have to give it out even to the states then.
No, the state has very low requirements for sharing information, and there really is nothing that requires a company to share any information of those type of studies that they do. And so you do come across a lot of studies that are done by companies in good faith, trying to get to the heart of a problem, but they're under no obligation to share that.
Yeah, thank you very much. I enjoyed your presentation.
Thank you.
Any other
Hi,
questions?
Dr. Parrish. Yes, Dr. Parrish, I have one. My name is Greg Zaris. I'm also faculty at the Emergency Management course in Public Health this semester. We had participated as part of the CDC in an investigation into a community where fracking was being done, and the folks were complaining of sulfurous gas getting into their water line and then eventually into their homes. And we found indeed that was so. Sulfur dioxide and methane were being pushed into their homes from the pressurization. Have you heard of any other issues? This was in Ohio, in a very small town. Have you heard that anywhere else?
I haven't heard of the you're saying the fracking pressure was enough to push the gases into a home?
Well, we could not really prove it, but indeed there were gases coming into the home through the water supply. In fact, well beyond, it was bubbling as the water was coming into the home. Methane was bubbling out of the water.
Yeah. See, this is where the problem arises for everybody concerned, is that as state geologists, I ran into a number of cases where things like that were happening on a regular basis anyway before drilling started. And so we would investigate them and say, oh, yes, this is where the gas is coming from. And we documented it. But since we don't have that on a systematic basis for the whole state, we have no way of showing that it's extraordinarily different, that things are happening now and it's related to the gas, unless you can do isotope chemistry to show that the gas is coming from the Marcellus horizon. It would be hard for me to see, well, in Ohio, I don't know the depth. In Ohio, it's probably relatively shallow. In Pennsylvania, it would be hard to see that the pressure of the fracking would translate into pressure change at the surface from a mile down. That would be hard to do. But in a shallow environment, it's entirely possible. In order to prove it, you have to do the isotope geochemistry, or you have to have the before and after data. And what I'm saying is we don't have any before data, so that's a lot cheaper way to go, is to get the before data.
Thank you. I enjoyed your class.
Any other questions? We have a minute or two. Is there any other questions for Dr. Parrish? All right. If not, I want to thank you again on behalf of the center and Millersville University, and thank you so much. And I'm getting comments here, people saying thank you for the great presentation. So have a wonderful weekend, and we look forward to seeing you sometime soon.
All right. Thank you.
All right.
Bye.
Thank you, everyone. Bye-bye.